Alright, so let's erase some of this stuff that we don't need anymore, make a bit of space on this board. So the 1 over 2 mpc squared survives, and then in brackets let's do everything carefully. So EP prime squared, EP bar squared, this should be a bar not a prime, I don't know why I switched it to a prime. EP squared, and then we have plus EP bar mpc squared, that's that times that, and then we have plus, well, minus EP bar times the square root of EP bar minus m squared minus mp squared c to the fourth. That's this square root times that e. And then we have plus this square root times that p, which is EP bar square root of EP bar squared minus mp squared c to the fourth. And then finally we have minus the square root times itself, so that's minus EP bar squared, and then minus plus mp squared c to the fourth. Okay, some rather fantastic things happen here. The first fantastic thing that happens is that these EP squareds cancel here. Right? And the next thing that happens is that these big square root terms cancel, and there's a term I've forgotten, this is what I'm worried about. The term I've forgotten is this square root times the mpc squared. So there's a plus mpc squared square root of EP bar squared minus mp squared c to the fourth. So quite a lot of stuff goes away, and what you're left with is 1 over 2 mpc squared, and then we have EP bar mpc squared, that's left, and then we have plus mp squared c to the fourth, that's left, and then plus mpc squared square root EP squared, EP bar squared minus mp squared c to the fourth. And notice that every term has an mpc squared in it, so this mpc squared outside cancels with that one. One of those two then multiplied together, and this one. And so you're left with E gamma 2 primed equals 1/2 of E P bar plus M P C squared plus square root of E P bar squared minus M P squared C to the fourth. But that's equal, as you can see, to E gamma 1. So we've just shown algebraically that if you do a Lorentz transformation on the energy and momentum of the gamma 2 in the rest frame of the target proton into the energy and momentum in the rest frame of the incident antiproton, then the energy you get back for gamma 2 in the prime frame is the same as the energy of gamma 1 in the unprimed frame. So that's the hard way of doing this problem. There's also an intermediate way of doing it, which I don't like as much, which is rather than to use the algebra to just substitute in numbers at an earlier stage and show that the numbers come out interchanged. The reason I don't like that as much is because it's not completely clear from the numbers you get out whether the numbers do really truly interchange or whether they just end up close to each other within the limits of the precision of your calculations. It's nice to show algebraically that the two things do actually swap, which agrees with the principle of common sense, which is the easiest way of doing the problem. So I hope most of you, or at least quite a lot of you, will have done the problem the common sense way and had the courage to pick up 6 marks for a sentence of explanation rather than doing it with a page of algebra. But the page of algebra is just as valid, and in the sense that page of algebra is the proof of the common sense result.